Okay, so hi everyone. Thanks for joining us on this first webinar between Zimmer and Peacock and Zahner Instruments. So first of all, thanks for everyone who's, I emailed a lot of you and you were kind enough to say that you were going to come, so I appreciate that. What we're doing today is we're just going to do a quick introduction to, well, my name is Martin Peacock. I'm a director and founder of Zimmer and Peacock. A few of you know me, some of you know me by email. Zimmer and Peacock's delighted to be a distributor for Zahner Instruments in the UK and in Norway, and in Scandinavia in general. So I'm delighted that we've got some people from Norway today. I know we've got some people from Germany, and I know we've got some people from the UK as well. We thought with this first webinar, we would just have a kind of light introduction. So today, Dr. Sebastian Field from Zahner is going to be doing the let's say the online demonstration. This is a bit unusual. It's not a slideshow or a slide deck. We're actually going to be doing some live electrochemistry. So we appreciate that we're doing this for real. You're all very welcome to ask us questions afterwards. Many of you have my email, so just drop me an email. So Sebastian, can you just do a quick introduction of Zahner, an introduction of yourself? I've promised everyone we're going to keep it to 20 minutes. What I'll do now is I'm going to, as I say, please introduce yourself. I'll start the clock and just make sure that we don't overrun. But please go ahead, Sebastian.
Okay, my name is Sebastian Feil. I'm Technical Sales and Marketing Manager here at Zahner Electric Scientific Instrumentation for Photonics and Electronic Chemistry. This company is located in Germany, north of Nuremberg. We are now for 40 years in the business, and we are a manufacturer of so-called electrochemical impedance spectroscopy machines, which we call electrochemical workstations. You can check out our website, for example, zahner.de, and here we will find a lot of information about our products. For example, here we have these electrochemical workstations, the Zenium X and the Zenium Pro. I also mentioned that we are active in photoelectrochemical applications. And there is our most famous, common, or used product is the ZIMS setup, which you can also get a lot of information on our website. You can use this in, for example, the ZIMS setup you can use for solar cell applications, photovoltaics, whatever, light emitting devices, and a lot of other applications which are done in the photoelectrochemical research. Okay, I also want to mention here, so on our website you can also find information about certain events. For example, also on our Kronacher Impedance Days. This is a very nice workshop that is covering a lot of topics coming from the electrochemistry and impedance spectroscopy, electrochemical impedance spectroscopy. We cover a lot of topics like batteries, fuel cells, solar cells, and this is a 3-day workshop taking place in April 2018 at Kloster Banz, that's in Bad Staffelstein in Germany, so also close located to Nuremberg. And of course, all the attendees of this session are welcome to be invited and can visit this workshop and learn a lot about impedance spectroscopy in general and photoelectrochemistry also.
Sebastian, I just wanted to say that I was an attendee at that workshop this year, and I mean it was really excellent. There were, it was very hands-on. The guys really brought equipment, and for those people who are thinking about fuel cells, batteries, or solar applications, it's a really good workshop. So I've been there. When you look at the photograph, I'm in that photograph, and I just want to recommend it to everyone. Yeah, that's me there. So just to say, I've been there. It was very good, very intense.
Here, this is Martin, for example. This is one of our co-workers, Dr. Michael Multerer, and this He shows an experiment performed on our SIM system. And as you can see, not only Martin was there, a lot of other people coming from universities or companies who were interested into electrochemistry and electrochemical applications, visited our workshop, and they learned a lot. I mean, this, you see, we have theory and also practical applications here, for example, also on batteries. And it get really first-hand experience. So, but our today's topic is the introduction into our software, and it's already running here. And we will test the software by measuring the cyclic voltammetry of a capacitor. It's here, you see it here in red. It's connected to a Zahner Zenium electrochemical workstation. And this is what you can see here on in the window next to the mainframe. And this is one of our workstations, electrochemical workstations. As you can see, you can also add several add-on cards, which simply increases the modularity or the versatility of this instrument. You can perform a lot of interesting electrochemical experiments. For example, like true parallel impedance spectroscopy by the PAD4 card, or transient spectroscopy with this transient recorder TR8M. And this will be also a topic on our corona high impedance days, just to make a refer to this event 2 again. But now we will continue with our presentation of the software. So the software is called Thales XT, and as you can see it here, it's already running. And well, on the left side here, this is the main control window. You have here on the left side certain lists. And this list, for example, you can choose different kind of applications. For example, you can, if you're interested in working batteries or in fuel cells, you have this drop-down menu, and you can select the methods for the specific application. Then, of course, you can also distinguish between AC or DC techniques. For example, AC technique is involving potentiostatic EIS or galvanostatic EIS, whatever, so all alternating current techniques. And additionally, when you have made already a pre-choice of your methods that you always prefer, then you can create here under projects different kind of projects which simply are, involving the preferred methods that you want. So it's much more easy to get much more fast and much more easy access to your preferred methods and applications that you always use for your experiments, for your research. And on the right side, we have here the parameter window. So where you can type in all different kind of parameters in order to define your experiment. For example, when we take a very classic one, cyclic voltammetry, then you can enter, for example, the starting potential, upper potential, so the upper turning point, and the lower potential, the lower turning point. And for example, also the stop or ending potential, the current range, starting time, so when it starts, hold time. Hold time is quite interesting, for example, for pre-polarization of your sample. Then also slew rate can be adjusted to your experiments, or how you prefer number of cycles, and how many sums per cycle, and so on and so forth. And let's start simply a very simple experiment measuring the cyclic voltammogram of this capacitor here. It's a 250 microfarad capacitor, and I simply will type in some values. So for example, the starting potential, let's start at minus 10 millivolts, for example. So I type in 0.01 and it gives me 10 milli. So upper potential we make 500 milli, and the low potential we make 700 minus 1 e to the power of minus 1. And you can see already, it doesn't matter how I type in the integers into the parameter side. It always transfers the numbers into the values, how the experiment can be performed. And it's quite nice. It's, let's say, more or less very straightforward. So now we have made our, or we have typed in our, let's say, the frame. And in order to avoid too much ranging, let's define the current range, also to 10 milliamperes. Or let's make it even smaller because it's a very small capacitor. 1 milli. Minus 1 milli, 1 milli. Starting time, let's wait for 3 seconds. And for example, hold time for 5 seconds. The slew rate, let's keep it for 100. And we make 3 cycles with 200 or 300 samples per cycle. And then you can already see the recording time. So one complete measurement will last for 90 seconds. So you see already everything is typed in, and let's simply press the start button. What now happens? You see here we have an online display, and on another screen the second one pops up, and you can see, for example, how the measurement is going on, what's going on during the measurement. You see here the voltage and the current. And you see here already in the second one, and where the cyclic voltammetry is running, it looks a little bit ugly at the beginning, but now the instrument realizes that the current range is not sufficient adjusted to the values coming back from the sample. So it starts auto-ranging and tries to define the perfect range for getting very good results from this measurement. This happens 1 or 2 times, so I mean, it helps you also to define maybe for the next time when you repeat the measurement again, then you can define the current ranges much more tighter, much more better to the actual values that you get back from the sample. So it's also when you have on samples, it helps more or less to define how's the response from your sample and how to adjust next time the parameters. Now it looks very good because the measurement is continuing. So we have already started the second cycle. And remember, we will measure three cycles, so it will continue now third time. You see it's moving here. Now it goes down, and now it's here. And you can also follow it here. So the voltage is now in minus 500, and now we're at the lower turning point, and now it goes up again. Yeah. Waiting until the experiment has finished. Okay, it looks good. There was nice clicking noise coming from the Zahner. When the relay is switching off, that means everything is fine. And you'll see also here we have this nice control lamp here. It's again green, meaning that the potential start has switched off. And now, for example, you can change the sample or something like that. So always have a look here on the green light. If it's green, it's safe to change samples or something like that. When it's still green, when it's still orange, yellowish, something like that, then it's the potentiostat is still on. It's still applying current or voltage, so you should go to the control potentiostat mode and switch it off manually if you want to change the sample, for example, or simply let it finish its measurement, and then of course it will automatically switch off. Okay, so now we have a very nice cyclic voltammogram of a capacitor. You recognize here the rectangle shape, so it's a very nice rectangle. And now we want to investigate it a little bit more, so we want to do some data evaluation, because we have now measured 3 cycles and we want to know what has come out. So I would suggest we save it. For that, I press here on the saving, on this disk, this old-fashioned floppy disk symbol. And here you see already this let's say, information window pops up where you can define, for example, the parameters of your sample again. So it was capacitance or capacitor. This is the system that we have measured. And here you see already there's some data available, for example, the date, the measurement date, the time, record time from when it started, when it is finished, the scan mode, and then you can add some other comments, for example, like comments 1 and what kind of capacitor and etc., etc., etc. And then we'll press save. And then another window will pop up, which is simply the save export direction. So it shows the way you will store it. And today is the 29th. And I write here, I call this folder capacitance CV. Okay. And the file, yeah, I label the file now, and now it's saved. And now we want to have a closer look onto the data. You see here, this is our data. It's now here still in the measurement window. And I will close it, and now I will start our analysis tool, the Thales XT analysis. It pops up here on my main screen. Now I put it here in the second one, and here this is how it looks like, the Thales XT analysis. It is a standalone program for evaluating cyclic voltammograms. We're now currently working on an EIS model editor, an EIS fitting tool. And this will be implemented in this XT analysis too in the near future. But in order to give you a first glance about the functionality of this kind of programs, I will just show the CV evaluation program, that is XT analysis. And I will have a look now on my file. And here we have the folder. And there's our cyclic voltammogram. Okay, in this, just to give you a short introduction to this analysis program, I will make an introduction to charge integration. So we have a cyclic voltammogram, and cyclic voltammogram means also, or doing this experiment, a specific amount of charges have been moved through our sample, and with the help of the charge integration tool, you get an idea how many coulomb of charges have been moved through the experiment. And this is something we will do now. And there you can also see what the program does, or can do, for example. So, for example, we can also split cycles. So remember, we have recorded 3 cycles. So I press the split cycling tool. And simply split. And then you see here on the graph, in the graphs window, that we have now 3 cycles here. And what is also quite nice in this program, you can see, for example, that you can modify the configuration of the view in the way you prefer it. So, and here, as I mentioned before, here you see also the different cycles, the single cycles. So we have a red one. You can change the color as you wish, or the thickness, or for example, to represent one of the cycles as a dotted one, the other one as solids. And now we'll simply make a choice. So I have now split the cyclic volumetric into 3 single cycles. And I will choose now one for the evaluation and for the charge integration, and I prefer the blue one because I like blue color. So I remove the green one, and I remove the red one, but still the data is available here in the data source window. So it's not lost, it's still available, it's still there for later preparations and later evaluations. And now I will start the charge integration. We can add also an additional baseline. Okay. And here, with this tool here, I started charge integration. And in the beginning, I defined the borders or the limits in which I will do it or I will perform the charge integration. So this is the starting point, and I will set the finishing point or the ending point here. So it's very easy, just press on edit, and then you can also move them along the cycle. So you can prefer any data point that you wish for doing this charge integration, and just press the integrate charge button, and then here we have it. Here you see that the baseline has split the view, so in the lower part and the upper part. And after pressing the charge integrate or with integrate charge button, when we press this one, the view simply has jumped from the current over voltage display to the current over time display, and you see here the red area and the blue area, which are simply defining the amount of charges that have been flown through the experiment. And here we have this items window where, for example, also the baseline is defined here. The integration start point and the integration ending point are also precisely determined. And of course, what kind of charges or which area of charges or which area of the cycle have been integrated. And for the upper blue one here, net charge of 35.4 nanocoulomb has flown through the experiment. And for this part here, now it's labeled in the dark blue, or is shown in the dark blue, 125 nanocoulomb have flown through the experiment. So to sum up, it's around 160 nanocoulomb have been flown, or of charges have been flown through the marked areas. So this is just a very small introduction into the Thales software, including the Thales analysis. We can also, I mean, there's a lot of functions here.
Perfect. So if I could just cut in for a second, Sebastian. So, I mean, a couple of things that I wanted to just sort of highlight are then that, this software is new, so there's a few users who will watch this video are actually on old software. So just to say that this is the new software, and I really like it's a very clean interface. And actually you can select your methodology either through application, or if you're a particularly, if you know that you want to do cyclovoltammetry or impedance spectroscopy, you can just select it. I realize that the software is in two parts. There's the data gathering part, which drives the instrument, and then you have a standalone piece of software that for the data analysis, the data viewing, the data manipulation. So, I mean, that's also a take home from this today. I'm just going to share my screen for a second, and I just want to touch on hopefully my screen's being shown now, because I just want to touch on at the beginning of this webinar, Sebastian mentioned the Zahner workshop next year on the 16th to 18th of April. Like I said, I mean, I have definitely attended this. I'm in the photographs. I recommend it to anyone who's currently a user or is thinking of being a user. They get some the Zahner guys are very good at electrochemistry themselves, and they also get a lot of external speakers in, so it's well worth attending. What I'm intending to do is I'm going to follow up with an email with everyone to sort of say, well, we're going to do this webinar again. Or next time, are we going to talk about fuel cells? Are we going to talk about batteries? Are we going to talk about solar applications? So I'm going to look for some feedback from you all about what you want us to speak about next time. Sebastian.
KIT 2018, the chrono impedance day from 16 to 18 of April 2018. And registration form is already online. The program will come very soon. And as you can see here, it is a very close atmosphere between our developers and the visitors of this kit. And you get really a lot of experiences from already established customers, and also from our research and development team, for example, from Mr. Steffen Fröber, who's sitting here on the left side of this image. And there will be also a lot of experiments available. For example, this is here a fuel cell experiment. And also you get an introduction for or into the art of good electrochemical measurements.
What I want to do is thank everyone for joining us today. I'm going to put this video online and invite everyone to one on we'll discuss offline what the next one will be. Will it be batteries, fuel cells, general electrochemistry, or solar?
Cool.
I'll be attending the Kronach workshop, so if anyone else is able to join us, that would be fantastic. Is that okay, Sebastian?
I'm perfectly fine with it.
Perfect. Okay, so thanks for everyone, and I'll send everyone a link to